Hello, future engineers, subscribers, viewers, and students. Here is a problem on distributed forces or pressure on dams. This is 3 in 1. There are 3 problems supposedly, but I solved this in just one slide. So here is the problem. The dam shown is subjected to water pressure. For A, compute the intensity of soil pressure at the base that varies linearly as pressure at A in kilonewtons per square meter, then to B, which is P sub B, kilonewtons per square meter. Compute, letter B, compute the factor of safety against overturning defined as the ratio between counterclockwise moments due to these active forces and counterclockwise moments about B to clockwise moments about B. Also the active force about B, the pushing force that will cause counterclockwise moment. So for this part B, Ry is not involved because this is a passive force. This is just a reaction. The forces that will cause this dam to either slide or rotate about B or tip over about B, we call that uh, tipping moment, or in this case overturning moment, would be that caused by F1, and the ripping moments caused by W2, W1, W2, and this F2 here, which will cause counterclockwise moment about B. Then for part C, locate where the resultant soil pressure crosses the base AB from B and compute the factor of safety against sliding as mu Ry over Rx, where mu is 0.7, the coefficient of friction, and Rx as the net horizontal force that pushes the dam. Assume 1 meter wide of dam into the screen and weight density of concrete is 23 kilonewtons per cubic meter. So this is the original dam, then this is the free body diagram considering all forces, pressure forces, such as the water pressure on this space. This is the headwater, which is triangular, and the pressure at the bottom, which is at this point A here, is 9.81 specific weight of water times depth of water 9 meters. So that's why we have 88.29 kilopascals. On this side, the pressure, by the way, is perpendicular to the face of the dam. That's why I use this pressure diagram. You may also consider this as we have triangular water section over this portion of the dam, and the pressure distribution would be horizontal, and the other one would be the weight of water equivalent to the volume of this water above this face, which is triangular. But you can also do that in your own way. But I just present this pressure distribution. Now, for F1, it is equal to volume of this pressure diagram. Take note that the dam is 1 meter wide into the screen, so it is just area times 1. Volume is area of triangle times 1. So the area of triangle is 1/2 base, 88.29 kilopascals, then height 9 meters, then perpendicular to the screen 1 meter. So 397.305 kilonewtons. While F2, this one, is 1/2 of uh, base 52.974 kilopascals. This 52.974 kilopascals is 9.81 times depth of water 5.4, so you'll get 52.974 kilopascals. For this inclined distance, inclined phase, take note that this is 5.4. The angle here is inverse tangent of 9 meters over 3 meters. This is 3 because that is 3. So inverse tangent of 3 is 71.565 degrees. Then we have a right triangle Opposite to 71.565 degrees is 5.4 meters. So sine of 71.565 degrees equals 5.4 divided by the hypotenuse. So therefore, the hypotenuse is 5.4 divided by sine of 71.565 degrees. And that's why you have here 5.6921 meters. So I removed that details because that is just trigonometry. And in order for you to watch closely and listen closely to the explanations, so that you will also think if you do not listen. Then, for this force F2, which I already computed, its line of action is from this B here, along the face of the dam, it is perpendicular to this face, is 1/3 of 5.6921, so 1.8974 meters. To continue, we have to compute weight 1, which is specific weight or weight density of concrete masonry, which is 23 kilonewtons per cubic meter times volume. The volume of this cross-section of masonry, concrete masonry, is base 3, height 9, then perpendicular to the screen 1 meter. So 23, the volume is 3 base times height 9, then 1 meter perpendicular to the board, 621 kilonewtons. Weight 2 is the volume of this concrete masonry, represented by this triangular cross-section of concrete masonry. Volume equals area of triangle times 1. So 23 area of triangle 1/2 3 times 9 times 1, 310.5 kilonewtons. Therefore, summation forces y equals 0, ry1 equals ry1 plus ry2 is just the sum of weights w1, w2, and the vertical component of f2, which is f2 cosine of 71.565 degrees. This is also 71.565 degrees, equal to this angle. So ry1 plus ry2 is weight 1 plus weight 2 plus the vertical component of f2, 170.767 cosine of 71.565 degrees. Therefore, ry1 plus ry2, which is equal to ry for the calculation later, is 979.177 kilonewtons. Call that equation na. To find another equation, we sum up moments about B for equilibrium. So we have ry1 times 4. By the way, ry1 is represented by this volume of soil pressure diagram, which is a right triangle, then perpendicular to the screen again is 1 meter. So it acts here. This is 2/3 of the base width, which is 6 meters. So 2/3 of 6 is 4 meters. While ry2 represented by this bigger triangle, and it is 1/3 of 6. So that's why that is 2 meters. So summation moment about B equals 0, ry1 times 4 plus ry2 times 2 plus moment of F1, which is F1 397.305. Then moment arm is 3. Again, 3 is 1/3 of 9 meters because this is triangular. Then equals counterclockwise moments caused by W1, 6 to 1. The moment arm is 4.5. 4.5 is 3 plus half of 3, 1.5. So that's why you have 4.5 there. While W2 is at distance 2/3 of 3, so 2 meters. So plus W2, the moment arm is 2, then plus the moment of this F2 here, which is 170.767 times moment arm 1.8974. Simplifying, 4ry1 plus 2ry2 equals 2509.65. Equation 2. Solving these two equations simultaneously with your calculator, then we get ry1 275.648 kilonewtons and ry2 703.529 kilonewtons. We then equate ry1 to the volume of the soil pressure diagram, which is area of triangle times 1 meter perpendicular to the board. So ry1 275.648, 1/2 PA times 6 meters, then perpendicular to the board 1 meter. So we get pressure at A 91.88 kilonewtons per square meter or kilopascal. So that's the answer to part A. Then RY2 703.529 is 1/2 of pressure at B, which is this, times 6 meters again, 1/2 base times height. Base is B sub B, height is 6. Then perpendicular to the board 1. So pressure at B is 234.5 kilonewtons per square meter. And that's it for part A. For part B, factor of safety against overturning, defined as counterclockwise moments of active forces about B to clockwise moments of the active force or forces about B. So, based on the figure, of course, we have to disregard this because this is a passive force. It's just a reaction. These are the active forces. So, the moment of W1 is about B is W1 times 4.5, W2 times 2, then F2 times this moment arm. We actually calculated that from here. Then we have the clockwise moment or overturning moment is, or tipping moment about B is F1 times 3. So counterclockwise moment again is W1 621 times moment arm 4.5 plus W2 310.5 moment arm 2 plus F2 150.767 times 1.8974, then divided by clockwise moments, which is just caused by F1, and it is 397.305 times 3. Simplifying the numerator, it is 3701.565 kilonewtons, the counterclockwise moment, or we call this writing moment, and the overturning moment, which is in the denominator, or the overturning moment, is 1191.915. Computing factor of safety against overturning is 3.106. So that is greater than 1, so that's it. That is for part B. Then for part C, compute the factor of safety against sliding, defined by that equation, where mu is 0.7, coefficient of friction, and Rx, the net horizontal force that pushes the dam. So mu Ry over Rx. Ry is already computed. This is 1, Ry1 plus Ry2. Rx is the net horizontal force, so it is horizontal force that pushes the dam, so it is F1 minus the horizontal component of F2. This is F2 sine of 71.565 degrees. So Rx, F1 397.305 minus F2 sine of 71.565 degrees, and it is 254.275 kilonewtons. We then sum up moment about B to locate Ry, the point where the resultant crosses the base of the dam, base AB from B. So it is this Ry here, moment arm is denoted by XB, then plus, because that is clockwise, plus clockwise moment F1 times 3, then equals counterclockwise moments. Since we already calculated the counterclockwise moments and the clockwise moments, so again, Ry times XB plus clockwise moments equals counterclockwise moments. Therefore, Ry times XB is equal to counterclockwise moments about B minus clockwise moments about A. The counterclockwise moment about B, counterclockwise moments about B is 3701.565. That's the value of the numerator, minus the overturning moment or the clockwise moments with the denominator 1191.915 instead of recomputing it. So XB is 2.563 meters from B. And finally, factor of safety against sliding, mu 0.7, Ry 979.177 Rx, the net horizontal force that pushes the dam, 254.275, and it is 2.696, which is still greater than 1, so it is safe. So this is the resistance to sliding caused due to friction, and the net horizontal force is F1 minus the horizontal component of F2. The resistance to sliding should be greater in magnitude than that of the net horizontal force that pushes the dam, so that the dam will be safe against sliding. So that's it for this video.